Hello, everyone, and it's nice to meet you. Today is our webinar Machine Learning Engineer. Let me please share this screen and start our presentation. So, today webinar is hosted by Programming School Black Screen AI, and we have 3,500 graduates which have already got their first job offer. And the school was founded in 2016 in California, and our instructors are from USA, Canada, and Europe, and all of them are working in IT companies. Here you can see photos from our offline workshops, and you can also join us in Miami this weekend, December. And also we have our YouTube channel. So if you're looking for motivation, please look through our interviews with graduates, where they tell their stories about how they started IT courses from scratch and then got their first job offer, and about job offer, our students are hired by companies such as Google, Meta, and Walt Disney. So if you're looking of working in big corporations, just you should know that it can be true with IT courses, that IT specialists are hired by different corporations, especially most of our students started their IT career with JP Morgan. And today we will talk about profession machine learning engineer, why it is interesting, and what what is waiting us in the future. Because we think that the market will grow, and as you know, today most of you, I guess, use AI in their everyday life. So we will learn today how machine learning engineers work with AI. So about also about the market, you see here numbers, how many businesses report that they use machine learning, and also that 76% of companies prioritize AI and machine learning than other professions. So just look through this statistic and make your own decision. And here is our instructor, Yash. Please take the floor and introduce yourself. Thank you.
Thank you. Uh, I might as well share the screen just
Yes.
to,
Okay.
yeah. Yeah, I hope it is visible now.
Yep.
Is it? Okay, great. So yeah, myself, Yash Yadav. I just graduated Northeastern University about a year ago, and I completed my master's in applied machine intelligence. And right after that, I started my career in uh, industry. I mean, focusing various industries. I started with finance, as in core finance, where I was building portfolios backed up with AI and a little bit of crypto analysis. And then I have, gone into fintech industry where I used to do more of GPT, Gen AI stuff, along with implications of Gen AI and non-machine learning in finance to make operations of big banks and big organizations as simple as and as automated as possible. And I have also taught R language. I also worked as data science researcher and NLP researcher for two startups. And I've worked basically more than 5+ startups, and I have built, I mean, I would say few AI models and deployed them as well. And this is a bit more about my experience in healthcare, aviation, and real estate, how I worked in these. And these are the technologies that I used in my work experience, which is something like it is used across multiple domains for solving almost similar problem. I mean, the reason why I'm saying similar is because we use similar algorithms, but for different aspects. So, going to the next slide, we'll learn about like what machine learning is and how does it actually work. So, before explaining it more in depth, I would recommend thinking it about mathematically, thinking it about like whenever I'm showing anything, just try to visualize it, how it will actually work. Just don't think about like I'm telling you an algorithm. You should think like, okay, I need to put programming language in it. I need to put some mathematics in it. Just don't do it right now. At this moment, it is an intuitive guide, basically. I would say just think about it. The more you think, the more you get to know how it actually works. So, in the start, let's just first understand what machine learning actually means. So, machine learning is basically a learning process by which a system improves performance from a given experiences. So, for example, just to simplify, there are three things: performance, task, and experiences. So, there is a system, and for example, there's a machine which wants to learn or which we want to teach. So a machine will learn to do a task T with some experience E, and which we will measure through its performance P. So it's just like there are three major things that we just look for in machine learning. So in standard coding functions or programming, what happens is like we put some data and we create some code, and computer holds that code and we get some output. For example, let's just say we have a simple calculator. I'm calculator knows. I mean, I have coded everything. Like if I want to add two numbers, I can just use add function. If I want to have modulus of one number, I can get the modulus of that. So it's just like you're giving it the number, which is data. You already written the code, which is program, and it resides in the computer and it gives you the output. What in machine learning is, it's like you put in some data, you put in some output. The reason why I'm saying output here is because you are teaching, like how I want to see the output. And I will give you this and I want this. And this goes on and on, and the computer will learn how this works. And the way this works is basically a program that which you do not have to do. It's just that there is a intelligent program, I would say, intelligent piece of code, which will have some kind of memory that whenever it sees a data, it it knows what output it is. So that's how it like it's a prediction as well. If I give you few matrices about what investment portfolio should look like, or what companies do I want in my investment portfolio, and the output, I mean the learned system will know that I want these companies based on these performances. So that's what it basically machine learning means here. So when do we use actually machine learning? Like, why are we even focusing on machine learning? Like, what sets machine learning aside from normal software engineering or software work? So ML is used when human expertise do not exist. So for example, at some time where you humans cannot be there to do some piece of task, which should be done at right at that moment. So for example, navigation on Mars, like we should better navigate in Mars, or uh, understanding the surface of Mariana Trench. At that moment, we can't be there, so we need some expert systems to be there on spot to learn things the way we taught them on ground. And humans can't, when we use ML, when humans can't explain their expertise, for example, speech recognition. So it's a classic example that you are in a concert and there are multiple voices around you, and you want to decipher one particular person's voice out of all these voices. So I mean, it's really hard for a human to understand that. Here ML comes. ML is really, I mean, really, really niche, and it really helps in disintegrating these multiple voices from the major one. It will take out small voices, people voices, and will uh, also take out the voice that you want to hear or that you are interested in. So that also has a, an ability to perform these complex tasks. So basically, the intuition behind how it happens is using Fourier transformation and decomposing the audio clips. That's what it happens. If you want to look more, you can learn more about this. So models can be customized. So ML is used when we I mean, statistically one function should answer a given problem, but that given problem is not just in one system or one field. For example, if I have to say, like, I want to predict what is the answer of the question given in a PDF. They can be PDF and related to mathematics. They can be PDF related to history or geography or political science, anything. But I need a system to understand whatever stuff that is written on the PDF, and in the end, it gets a question and it perfectly answers that. So that system has to be learned. That system should use machine learning to first understand the given concept, then understand, okay, you will be asked the question, and then understand, okay, this is how you should answer. And then in the end, you can ask the question from a given PDF and you'll get the answer. And model can consume a huge amount of data. So, I mean, just for an example, uh, aeroplane turbines generate petabytes of data in a minute. I'm saying petabytes of data, meaning it's so huge that your single system cannot handle. I mean, you need like thousands of different CPUs and memory cards just to handle 1 minute of data created by turbines. So to handle these kind of large data, and just for example, I'm giving you one use case where machine learning is useful, is that uh, for example, if the speed of turbine is, let's just say, 100 miles an hour, just hypothetically, if speed goes 1 mile an hour plus or minus, there is a huge possibility that a turbine is having some issue or it can burst in few seconds or anytime soon. So if you want to detect that, if you want to detect beforehand if that's gonna happen or not, you can have a system trained that it looks at usual values of turbines. Okay, this is how usual value looks like, and whenever unusual value comes, it detects it. It knows that this looks unusual because I haven't seen this before. So it will tell you that this is a fault. I'm seeing this fault in the turbine, and you may turn it off or you may correct it. So basically the reason why I'm saying is this is another example or use case of ML when we have huge amount of data and when it is coming in real time. So another example of understanding what machine learning can do is like think of a there's a task that requires machine learning, and it is very hard. So for example, in these numbers, it is very hard to say what two, I mean, what kind of digits are two or represents a two. So, and for example, the right side, the top right left box, sorry, top right red box shows, I mean, it seems like it should have been three, but it was cropped somehow. And similarly, second red box, it seems like it is also three or between two and three, we don't know. And similarly, if you go in the bottom red box, it has two digits, and we don't know if it is seven or two or don't know what it is actually. So it is very difficult for us to even think, like whenever you're reading someone's handwriting, you might not figure out few alphabets or few numbers because the way they write. And machine learning systems can recognize these digits no matter if they have seen some kind of similar thing or not. So let's just say like if you want a system, like if you might be seeing some robots that can have visual perception, like they can visualize things, they can see humans, they can see cars, or best example is like Tesla uh, cars. They visualize surroundings. They let you know that there is a car in front of you, there is a car in front of sorry, in on the right of you, and there is a pedestrian crossing by. So there are all things, and there are all machine learning models that do understand this and eases our task to read a paper, for example, read someone's handwriting. It is easy using machine learning, and that's what machine learning does, and that's why it is helpful for us. It's not like normal thing like we should not do it or we should do it, but basically the the reason why we do machine learning or why we use machine learning is that it helps us statistically predicting uh, something, or it can do complex tasks, it can do multiple tasks, which normally open for which are like really time consuming and hard for normal humans to do. Few more examples of machine learning is like recognizing some patterns, generating new patterns, recognizing anomalies, like I've mentioned an example of turbines, doing some prediction. So we'll look into these things in upcoming slides. And some of the applications of machine learning is in web search, as in computational biology. So I'll explain once, like each use cases for each of these things. So for web search, it is like you might have seen uh, how many searches, like there is a whole bunch of statistics on the web that these many people are coming on the website and they are looking on this web page and they are looking for this particular post more than the other ones. So they customize their website in a way that engages more user to their website. Similar like what Amazon is doing, they are using some recommendation systems. In the end, whenever you select a few of things and you put them in your cart, it also tells that people also bought this, or we think that you might like this. So there's a whole machine learning thing on the back to just to do that thing. In finance, a classic example is that whenever you do some transaction and whenever sometimes your banks let you know that we feel that this transaction is suspicious, so we are not authenticating it. If you really did this transaction, please respond, something like that. So it is all automated. It's not like there's person standing in the back and that is monitoring your transaction. It's not like that. It's a completely automated system which is backed by machine learning. Space exploration is again similar to Mars rover. So the way Mars rover are perceiving Mars surface is using radar technology, LiDAR technology, and there is whole machine learned learning system inbuilt in Mars rover that understands like, okay, there's a elevation there, you need to go slow. There is a, you know, a big rock that you need to turn around, something like that. So there's a whole machine learning system in the back as well. In information extraction, something like, for example, if you are tasked to read a 1,000 page PDF or 1,000 page book in an hour, you can't do that. Or I mean, the best way you could do that is just like skim through it and look out for what are the headings and what are the important things. You just mark those things up, and still will take like more than a month or 2 months or 3 months, for example. But with machine learning, you can do that in split seconds. The way it is working is like you teach the machine like, okay, I'm giving you this, out of this I want to find these important things, and the reason why these important things are as follows. And giving these instructions, the machine learning model will understand that, okay, user or you want to extract these things from given PDF or a book in this way, so it'll do the work for you. Um, for computational biology, again, it finds out if there is a tumor, for example, on in your MRI scans, which is time consuming for radiologists to find out or detect that. And there are a lot of few more of these, and a lot of these are like self-explained. Like the way social media ML works is similar to web search work, and e-commerce is again similar to web search, and robotics everybody knows, so I don't think there is much explanation needed at this point. And so there is this really classic thing again that there was like at a moment at a time, people trained a model which learns how to play checkers, and model learned quickly first. Second, model was so accurate that it started beating normal humans in their own game, right? So its total statistics in the machine learning model was able to catch around like a million of combinations, how people play or how they can be played. So after learning all that, it was completely unbeatable by humans. So the way we define what learning task is few of these. Like these are for all examples. Let's just first understand the first one. So the task T is playing checkers. So your performance will be evaluated by percentage of games won in against an arbitrary opponent. And your experience will be playing practice game against itself. All right. So TPE. All of only these three things you should always remember whenever you're thinking of machine learning. Again, next task is that you are recognizing handwritten words. Your performance would be percentage of words correctly classified, which is obvious, and your experience would be a database of human labeled images of handwritten words, and so on. Like you might see a lot of these things. So state-of-the-art applications of machine learning, yeah. So autonomous cars, which is uh, Tesla, I would say, is a classic example for this one. Everybody knows Tesla, I hope. And they so in first image, it seems so. I mean, this image depicts more or less what Tesla does. So it identifies what are the vehicles or what is the object that they're seeing or size of that object, structure of that object they're seeing in front of the car or around the car through few of the technologies that I will show you what are those. But these are the how the cars look like, and they have all sensors ingrained in them. They can see or detect humans, cars, animals in front of that. So they can better they can have better control on the car, because for humans we can't make split second decisions when we are like about to have an accident. But with this system, I mean, cars can itself make decisions if they want to stop the car, they want to turn around. So that's why we call autonomous cars. So this is a bit of a diagram which mentions like how decisions are made or how data is collected from cars and how I mean I would say like if you want to build an autonomous car, you should have data, all of this data, along with visual data. On based of these kind of things, you can train a complex model to understand I mean, to train your own autonomous car. And I hope that we will try to learn that in this course. So these are all things you don't have to actually think like you are. It's not like you have to read all of these and you have to understand how these things work. Really, you don't have to do that. It's just that the reason why I'm showing this image is that I tell you that there are some gadgets using I mean, there are some gadgets that are used in the cars or autonomous cars, and that's the way the people are collecting the data to improve their cars or their system to learn more about accidents and to perform better or to be efficient in some bizarre or I would say dangerous situations. Again, this is the same thing. This is how terrains are mapped. For example, I was mentioning about Mars rover. This is again how they are mapped, and it isn't like real time. Whenever they see, like think about like you're moving on the road and you're seeing a rock in front of you and it's coming close by, so you want to make a turnaround. So this is our human intelligence. How do we make that for uh, a rover? So that is called something called reinforcement learning, which we will see. I'll also mention you a diagram for that as well. So there is also something called deep learning. It is, I would say, a big brother of machine learning. But the way deep learning works is that there are multiple, or there are so many neurons. Think of like a neuron. So think of like this is a sheet, and each sheet is built up of like thousands, not thousands, but hundreds of neurons, right? Each neuron's work is shown in the right side. So each neuron work is to understand an edge in this image, right? So some neurons understand edges which are 90-degree or which are at 95-degree, or a few types of other neurons which only understands horizontal edges, and there are others which only understand vertical edges. So these are all the things like at first layer. And when it gets more complex, when you add more layers of neurons, it gets more complex. Like it will learn curves, then in the end, it will learn the objects, the complete face. That's how it understands an image. And in the end, you will see your image is now converted into exactly like numbers in in a single strip. Again, so there are uh, basically four types of machine learning, or I would say learning, but only three are majorly used. One is the one which is not majorly used is called semi-supervised learning, which again is for complex tasks given when you understand or when you know that unsupervised and supervised are not going to be enough. So you need to be having a mixture of these two to achieve a goal. So let's start with supervised. In supervised, you do one thing, like it's really simple. You give the data and you give the output and you expect the output. So it's a bit tricky. So it's not like you're giving the same output and you're expecting the same output. You're giving the data and you're giving the output. So for example, there are two data sets. I will say let's consider an Excel sheet. Uh, Excel sheet of 100 rows and let's just say two columns. So first column is something like square foot of house. Second column is price of house. So I would say that I want to have a system which is intelligent enough. So if I give that system the size of a house, it will tell me this price of a house. So how do we achieve that? So I'm saying like we have one data set of 100 rows and two columns. So so there are two things in supervised learning or in all of these machine learning. It's our training set and testing set. So in training set is supposed to be a bigger chunk of the overall data, and set is just to test like if we trained it well or not. So testing set, for example, you have 100 rows. I'm gonna say like I'm gonna keep like 75, 25. So 75% of the row of the total data set is my training set, and the rest of it is my test set. So now just think about training set. So in training set, we have two columns. First is size of a house, second is price of a house. And we have 75 rows. So I'm telling the model that I'll give you first column and look at the size. And for this size, the price should be this. For this size, price should be this. So what I'm saying is take 45 rows for column one. For these 45 rows, this should be the second column, right? I'll teach for all 70, I'll pass through all 75 rows and then I will pass next 25 rows just to test if the training worked or not. In the end, while testing it, I will find out the performance that how accurate was the model in predicting the price of the house by just looking at the size of a house. So this is basically means that I'm giving an output along with the data, expecting an output in like predicting an output, or I would say that output that I'm expecting is basically a prediction or a forecast. That is what happens in supervised machine learning. So think of like your first column, and these are like blue ones are the dots. It's like data is random. They are like randomly distributed there. And for supervised machine learning, there's a task called regression. So in regression kind of task, we try to make a function to predict y given x, where y is a real value and x is your input data. So in regression problems, we just try to find what is the best fit line. So the reason why I'm saying best fit line is because any line which best fits the data, I mean fits these points, can best explain the points. And the reason why I best explain the point because I need to have a system intelligent enough which can explain to me why this price is related to this size of a house. So in regression, it's like finding the best fit line. And this one is classification, and you see classification by means it's like you are trying to classify between few things. Like it can be two things. You are trying to classify between if this image belongs to a cat or a dog, or if this breast cancer is malignant or benign. So one says here, it says malignant, zero says it here as benign. So, and it depends on the tumor size, for example. If tumor size is low, it is benign. If tumor size is high, it can be malignant. But here in this part where at same almost same tumor size, the cancer can be malignant or can be benign, right? So these are the tricky things that model can learn, but for us humans, it is difficult for us to understand. This is again another example of different type of classification. It's like if your age is small, even if the tumor size is high, it can be benign. If the gradually your age goes up, if the tumor size also goes up, you are more tends towards to have a malignant cancer, right? So it's like it understands the distribution of the data or how data is distributed on the graph, which norm for normal humans we can't actually think of distributing all those 100 points, but for machines they can do that. So in unsupervised learning, so as I mentioned, supervised learning is that you basically making you're basically supervising the machine learning model with your output. Remember I said like data and output, it gives me the output. So in unsupervised learning, it's not like that. It's something different. You just throw in the data. You just let the machine do its stuff. So for example, here I'm putting on the left side, I'm just throwing the data itself. And on the right side, it is giving me different colors or different classes, for example. So the reason why it is giving me different classes because that's what a model understands. Model thinks like, okay, you have given me 10 things, and I think first two things are similar, next three things are of one kind, and rest of all are of one kind. That's how it is doing it is creating clusters, right? And that's what unsupervised machine learning means. And you can find these things in genomics application, like in healthcare field. It's really important, but just don't be frightened about looking at this picture. But the reason why I'm showing you this picture is because, like, think about like there are some red kind of classes, there are maroon kind of classes, there are light green, there are dark green, there are some blacks, right? So unsupervised learning is basically you are trying to group similar things aside. You are grouping similar things aside. That's what it does. Similarly, like in this market segmentation, in social network analysis, in astronomical data analysis, and organizing your computer clusters as well. Oh, it is again similar one. I've mentioned this before that in out of from a crowd, and if you want to hear one single person's voice, machine learning can decipher multiple voices. Like this voice looks like I mean this noise feels to be a different pitch. This noise feels to be a different pitch, meaning that this person is different, this person is different. So it can actually pick out voices depending on who is talking, right? So reinforcement learning is the one that I was talking about previously. It's like really teaching an agent or basically if you know about NPC non-playing characters in any video game, you see like they're automated. Like whenever you reach a certain level, they come to you, they do some behavior, and they just go by and you do your own stuff. So those NPCs are coded actually in previous games, but now these times at these points, for example, in SimCity or in GTA 6 or GTA 5, if you know that, people or researchers have created all AI agents, which can have their own intelligence, which can work in their own field, own game, own house. And the reason why they are doing that is because they have been trained on uh, in a given environment with a reward policy and learning function. So basically, this is how it works. You have set up an environment that, okay, you have to be between these two lines, or whenever there's a curve, you have to stay between these two lines, and that's how you uh, make an agent drive on a road, right? So the reward would be, if you do it right, you get plus 1 point. If you do it wrong, you get minus 1 point. And your aim should be to have as maximum points you can get in positive. If fulfilling all these conditions, you train an agent. For example, this is a classic one. So think about, like, the way I'm training them is by scoring their scores that they're scoring. Basically, the reason why I'm saying this is because that let's just think about that. There are blue agents and there are purple agents. The environment is the field of football, and how they're getting a reward is, if they score one goal, they get plus 1 point, and at the same point, the other team gets negative points, which makes the opposite team to play more or think about other strategies. And that's what reinforcement learning is, because that you are reinforcing their own actions onto them, depending on the reward function. How do you want to reward them if they do it right, and how do you want to punish them if they do it wrong? So framing a learning problem is as simple as that. You need to find a target function, basically. So you need to find training experience, which is nothing but your data. It can be anything. It can be tabular, it can be voice, it can be video, it can be anything. And you choose what exactly need to be learned. For example, I gave you an example of house size and house price. So in that, if I'm saying, like, I wanted to have house price, then my target function is house price. And if I say I wanted to learn to have house size, then my target function is house size. And then choose how to represent the target function. As I mentioned that I want to represent my target function as, let's just say, my output. So that's how basically you represent your target function, and choose a learning algorithm to infer target function from the experiences. And there are multiple learning algorithm. You It depends on what your task is. If you want to have regression, or if you want to uh, train a model which understands how to classify between two given things, you use different kind of algorithm. Training versus test distribution. So we generally assume that the training and text examples are independently drawn from the same overall distribution of data. So it is very important to keep, sorry, it is very important to keep both testing and training data independent. Reason being is that if your testing data is coming or is a part of your training data, I mean, your model has only learned from training data. If you're doing that again, if you're testing your model on a batch of your training data, it will perform 100% correct because it has learned from that. It has previously seen all these things, right? So to make it uh, unbiased, we need to have two independently data sets. One is training and the other one is test. And we also call this IID, which is independently identical and independently drawn, or distribution, you can say. Yeah. And if examples are not independent, it requires collective classification, meaning, like, whenever your statistical outputs or calculations mentions that it is, like, it seems not to be independent, seems like there is some correlation between those two data sets, you need to have a bit more specific to find out how you can make them independent. And basically, so every ML algorithm do have three things. So first is representation. How are you representing your ML algorithm? Second is optimization, how you're trying to optimize your ML algorithm. Evaluation. Third is evaluation, and how are you evaluating your ML algorithm, how it is performing. So basically, there are a few names here I'm going to throw up here. So first, like in case of numerical functions, so let's just first think about like how do you do representations? It can be symbolic, it can be numerical, it can be instance based, or it can be probabilistic. So for numerical representations, you can use linear regressions, you can use normal perceptron, which is nothing but neural networks, normal neural networks, or I would say simple neural networks. You can also use SVM, which is support vector machines. For symbolic functions, you can use decision trees. So the reason why I'm saying all these names because these are the algorithm names, and they are a bit more complex to include in this webinar. So I would say just I'm just letting you know these names that we have these kind of algorithms as well. So in decision trees, we have multiple trees taking a decision about whether this data should relate to one class or another. That's how it works. And there are a few more of these. And for optimizations, and so the reason why I'm saying optimization here is because that when you train a machine learning model, it I mean in during the training process, model can learn something else. Model may not learn. So you need to put some pressure on the model basically to focus more on learning and focus on uh, I mean, learning properly. And the reason why I'm saying properly is that model can just say like if 90% of your data is from one class, I'm gonna say every time I'm gonna say every data you throw to me, it's from that class. But that should not be correct. I mean, whenever you want to, I mean, whenever you have a data which belongs to other class and the model still says that it belongs to the other one, it's wrong. So we need to have that kind of few things to punish the model. If it predicts wrong, you will be punished, and there are these algorithms which punishes it. In ML in practice, so how does it actually looks like when you're working in machine learning? So first of all, you need to understand what the domain is, and you need to have a prior knowledge, like how what data of that domain means and why is it important, what how it is important, how it is actually created, and what is the goal that you want to achieve using this data. Second is your data integration. For example, if you have data coming from 7 or 8 resources, you might want to integrate them before doing anything. And even before integrating them, you might want to select that, okay, out of these 10 resources, I think more information can be drawn from these 2 resources. So that's data selection. And cleaning is that all data cannot, uh, I mean, data in real world is dirty. So dirty means that it has multiple things. For example, it can have empty data. So, I mean, you data creator supposed to put some data at a given point, but it didn't, maybe because of human error or maybe because it wasn't even recorded. So it can have null values in that. It can be something like it can be biased. So after this, when the data was being created, after a certain point, it data is all faulty. It can be that. So you need to find what are these faults and you can just clean them. Sometimes in numerical data itself, you get dollar signs or alphanumeric characters. So you might have to remove those alphanumeric characters when you are treating numerical values as numerical values. You cannot have alphanumeric in them. And you do some pre-processing, you do some in previous slide I mentioned they should be independent. They should not have any correlation between all these columns, for example. So this is a part of pre-processing here, that you remove the dependency between one uh, column to another column. This I'm strictly speaking about tabular data. And then you have a model which you want to train. And after training, you just interpret the results based on your testing set, basically. And then you consolidate everything and then deploy it wherever you want to deploy it, and then go back again. Like, did you really solve this problem by understanding the domain again? I mean, not understanding the domain again, but data coming in daily changes. It's not like data after 1 week won't be same as today, or data we got it today is not same as the data we got a week prior. So data changes every day. So we have to make an algorithm which can adapt to all these changes. That's why we do this kind of loop again and again. And that's what we call as maintenance, which is a tedious task. So that's it. Thank you so much, and let me know if you have any questions.
Thank you, Yash. Um, so while you're writing your questions, I will proceed with the presentation and tell you about the course, because I see already some questions about the course, about the price. So I will answer those. And if you have any questions for Yash, you can write down them so we can answer in the end of the presentation. Thank you. So let me share the screen, please. Okay, thank you very much. So, who can become a machine learning engineer? So as you see, there is no gender and age difference or some privilege if you're man or woman. It doesn't matter. The most important thing is your experience and your education. Any certificates if you have, you should pay attention on this. If you have some basic, if you graduated from, I don't know, computer science or some math education, it will be okay. Also, if you have any experience in IT, for example, you as a full stack developer or tester or I don't or maybe DevOps engineer, any IT background is also good to um, make your qualification higher and learn on machine learning engineer courses. And also machine learning engineer is profession for those who can work in a team, because it's a lot of teamwork. And also you should be attentive to details. So if you see those qualities in yourself, so you should think about machine learning engineer profession, because this profession right now is the right time to start, because the interest on to this profession is growing, and you will get your job offer really fast. But if you will wait till machine learning become really popular, then it will be harder to get job offer, because there will be a lot of specialists, and companies will you know will ask more from candidates. So here is our motivation slide. As you see, junior specialists are those who are up to 12 months experience, and the salary here you see the salaries like year salary, not monthly. And here you see our screenshot from Indeed, and also you can look through LinkedIn, especially in your state. What are the salaries for machine learning engineer profession? And what about the course? What you will learn? There will be few months about learning Python, then few months about learning math, and then you will learn machine learning engineer. And after the whole course, you will go to internship to get experience. Also, in our course is included interview preparation, where you will study with our HR manager and you will prepare for interview all the behavior questions, and also you will build your CV and LinkedIn profile. So about timeline, the duration of the course is 6 months plus few months if you will learn Python, if you already know Python. So the course will take 6 months. And after the course, you will join internship where you will be at least 4 months, and then you go to the market. The start of the course is February 3rd. So you have enough time to prepare yourself. Here is some main topics of the training program. If there are any questions about the program, don't hesitate to ask us. And the main slide is here. Your special offer only for participants of those webinar. You can scan our QR code and our manager will call you back, answer the questions, and send you the invoice for the payment. We have only 5 to 6 places in our group. We don't make big groups because machine learning engineer is like there's a lot of information and we should work with each student. So we make groups about 5 to 6 people. And on this slide, let's answer questions from our chat. So the first question is, yes, are there any math prerequisites required for this course? Yes, please.
Mathematical prerequisites for this course should be basic high school level math, which includes linear algebra, um, calculus, differentiations, matrices, determinants, vectors, and these kind of things. And if you like really want to know the nitty gritty of algorithms and even the deep neural networks, I mean, if you want to go deeper into it, I would say uh, read about complex matrices, matrix calculus, and read about you need to understand how you need to be able to visually understand or visually create how things are moving. Like create in your mind, like think about how what is matrix multiplication? How does it look like in your mind? So basically, I would say these can be mathematical prerequisites for this course, but no need to worry about it because these are not that hard. Even if, I mean, if you have taken mathematics in your high school, it should be pretty simple for you. Yeah.
Mm-hmm. Thank you very much. And also here's the question. What is the difference between test data and training data and the output which are given as input to a model?
Yeah, so test data and training data is basically like uh, think about model as a small child. You want to train a child for a particular task, and you want to test the child as well if the child is performing or has learned anything. So right, if you want to train it, like you, for example, you let the child do, or you explain the child that this is what you will get and this is what I want from you. So do your task or do what kind of whatever job you had to do. So I train them. So for you train the child multiple times or 10 times, for example. So that is training. And the data I used to train that child is training data. And similarly, if the data that I will use to test if that child actually learned something, then that is my testing set. So basically, if I'm looking at 100 rows, for example, a tabular data set, and so first 75 or a larger chunk basically, it is all on you, whatever you want to decide. Like it can be 50-50, or it can be 60-40, it can be 70-30. So the larger chunk you choose to train the model is your basically a training set. And leftover, which is used to just evaluate how better your model works, is the testing set.
Thank you very much. And what knowledges of mathematics are required to start the course?
I mean, just to start the course, you don't actually need high-end mathematics. As I mentioned, first answer is that you only need to understand. It's not like you need to remember everything. It just if you understand all these things in past, that's okay. You can really understand all these things in now. So yeah.
Mhm. Thank you. And also, here's a question. Um, the main purpose of writing models is to optimize tasks or processes, while programming languages and frameworks are just tools to achieve this. Am I correct?
Yeah, basically you are 100% correct, I would say. And in software engineer, it's like you use tools to build a bigger tool, right? But in machine learning, it's like you are using small tools to create a, a learning process, I would say, or a sophistication process to perform a task. So basically, what it means is machine learning is more complex thing intuitively, not programmatically or not skill. I mean, with respect to skills, it's not that complicated, but intuitively, the same program can work. It can be very, very important because it is a machine learning program. And the same program can be not much important because it is from normal software engineer. So as you said, so software engineering frameworks are just tools, and machine learning algorithms are actual things that you create from those tools to solve something.
Mm-hmm. Okay, great. And one more question. Do you use some sort of sorting algorithm?
Sorting algorithm, I actually don't. So in machine learning, it's nothing like sorting algorithm. I need to be careful about the big O notations, meaning like time complexity. I should not be worried about complexity for now. Reason being is that uh, the model will be cached into memory. Model will have its own memory. The model will work on its own pace. If you try to confine the model, you are literally meddling with its performance. If you want model to work fast, its performance will be degraded. If you don't want that, let the model work by its own memory. So having said that, I generally don't use sorting algorithms, but at times we might need it because sometimes data is we want to just to find out how data is being represented. I just want, for example, I just want to sort it out first. then I have to think about like visualizing it. So sometimes we do use it, but it's not like we code the sorting algorithms first and uh, searching algorithms. We don't use it. We don't use sorting algorithms as much. Software engineers does.
Mhm.
Yeah.
Thank you. And the last question is for me. Here, Maya asks, so the internship project is available for those who live in Canada as well, isn't it? Yes, it is, because the participation in our project is online. So you participate in project from your computer, from your home, and it's not full-time job. You spend like hours in our project, as much hours as you can. Um, you can spend like 4 hours every day, and someone can spend more. Um, but what is required is that you should participate at least 4 months. So that's about our today's topic. Thanks everyone for participating and for asking questions. Thank you, Yash, for your time. And we will wait everyone in February. Let's start new chapter and study new profession. Thank you. Have a nice evening. Bye.
Thank you. Bye bye.